For the second two problems for number 11, we've got two different transformations happening here. If you look at this one here, our pre-image is here and our image is here. You can see that I can't just slide this, because if I were to just slide this, the whole thing would slide over. So this can't be a translation. So if it's not a translation, it could either be a dilation, which it looks like the size is preserved because the distance of ST is 2, S prime T prime is 2 as well. So it's not going to be a dilation. So that leaves with either a rotation or a reflection. So right off the bat, I can see that there is overlap of the two figures here. If I look, I'm fairly certain that this is going to be a reflection just by looking. But if you're having a hard time looking, a way you can check to see if something is a reflection is you can draw a line between each of the points prime and originals. And what you can do is you can figure out the midway point between each of those lines. So if this whole S to S prime is 1, 2, 3, 4, 5, 6, half of that would be 3, so this would be right in the middle. R to R prime has a distance of 2, so this is right in the middle. Q and Q prime, this is right in the middle. So since all of those are taking place in the middle, that means that my line of reflection is the y-axis. Another thing that you could have done is you could have recorded where S and S prime were, R and R prime, and compared those. Since S is at 3, -2, and S prime is at -3, -2, R is at -1, 1, 2, 3, 4, -1, -4, and R prime is at 1, -4. You could have looked here and said, okay, I can see that the same number is used in the same location, but I changed the sign on my x's for both. My y's stayed the same. So this is definitely going to be a reflection, because we can see that we went from xy. If I write my rule, I went from xy to, my y stayed the same, but all of my x's, they changed sign. So that's the opposite of x. And then we can see that it's also a reflection, because our rule says if you reflect over y, y stays the same. If I had reflected over x, my x would stay the same. So reflect over y, y stays the same, x changes. So this is my rule right here, which is -xy. As always, you can always plot some of the points or write down the coordinates and see what's happening there to help you write the rule along the way. For this one here, I can see that if I were to take my shape and just push it down, I would get this. Oh, I'm sorry, I messed up. This is the pre-image, this is the image. So really I would need to push it up, not down. It was hard to see the primes. Make sure that you can look for those primes. So to get from Q to Q prime, I'm going to go 1, 2, 3, 4, 5. So I'll go up 5 and left 3. So if I go left 3 and up 5, that will get me from Q to Q prime. That will be the same for R to R prime, S to S prime, and P to P prime. So now I just need to say, if I'm going left and right, that's going to affect my x's, because that lines up with my x-axis. If you're going left and right, the x-axis goes left and right. And if I'm going to be moving left, if you start at 0 and move to the left, you'll be going negative. You'll be subtracting. So really, I will be subtracting 3 from x. And if I go up 5, up and down deals with our y-axis. And if you go up, it's becoming more positive. You're adding. So this will be y plus 5.